Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA Coaching Center, Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing free educational content every single day in our YouTube channel. So my dear students, ee video lecture series lo manam AE-AEE-CIVIL aspirants koraku ee video lecture series anedi provide cheyadam jarugutundi. In this video lecture series, we are going to be discussing about the subject fluid mechanics. Topic is fluid properties. So my dear students, those who have not subscribed our channel, please subscribe the channel, press the bell icon to be notified for every updates and watch the video till the last. And at the end of this very video, I am going to be giving you an exciting golden opportunity provided by SpaceGate app. Okay, let's start the video now. Observe here. So now we are discussing about the next property. First of all, let's go back and see how much we have discussed so far. First property that we discussed about is area. 3 area formulas for cylinder, 3 area formulas for sphere, units of area. Then we have volume 1 TMC we have seen. Then masses 456, 453 grams. Okay, if you want you can write to be precise 453 itself here. Okay, 453 grams. 456 is approx correct, but if you want to exact, then we can write 453 point something also will be there, that is 453 grams and 0.453 kgs. This is kgs, 453 grams. Okay, go through it to be precise now. So now we know about area, volume and mass. Let us discuss now the next property, that is we having mass specific volume. Specific mass, first specific mass, then we will discuss about specific volume. Specific mass, mass density and density. It is denoted by symbol rho. The formula is mass by volume. If you see the meaning here, what is the meaning of density, sir? It is closeness with which, degree of closeness with which molecules are bounded or arranged in a given volume. Okay, if you see solid, molecules are closely packed. Liquids loosely packed, gases very far away from each other. So if you take an example of let's say metal, any metal, if you're gonna see, suppose steel we are taking, steel is having a density of how much? 7850. Comparatively with water is having how much? 1000 kg per meter cube. And then we are having, let's say it is air density is 1.2 kg per meter cube. Upon this example, what we can say, solids are usually higher density than liquid than gases. But when we discuss about only water, so here we are having water, ice molecules are very far away from each other comparative to water, liquid molecules are closely packed. Okay, so this is ice, here we have water. So here this case does not valid because density of ice is around 900 kg per meter cube, whereas density of water is 1000 kg per meter cube. Remember this. In case of ice and water, this condition does not valid of solid is having higher density than liquid. Okay. In previous studies in 9th class, 10th class, we will be learning about this example. Here we will be having air and here this is water. When light is made to pass from which medium to which medium? Rarer medium to denser medium. Then what is going to be happening? Light is going to be water refracting. Okay, towards the normal, away from the normal, depending upon from where to where it is going to be transmitted. So there you will be learning about this word, that is denser medium, rarer medium, From where we can understand this density meaning? Density is molecule closeness, okay, which is independent on mass. So a new formula that we are gonna write it here, an important point, that is density is, it is independent on mass. Remember that. For example, suppose I am taking water. If I am going to take this water into two different containers and make it half, okay, suppose this is 1 kg, now it is half kg, mass is changing, yes, mass changes, yes, but do density change? Here density is how much? 1000 kg per meter cube. What is the density of water here? 1000 kg per meter cube only. That is, per meter cube the value is always 1000. It never going to change. Mass changes, density does not change. Mass changes, density does not change. That's why it is independent on mass. And the properties which are independent on mass are called as intensive property. What is it called as? Intensive property. Okay, go through it once. So now we know about density, basic important points. Yes. Let me write it at one place, whatever we discussed about. Okay, one more time. What are the names? First of all, it is called as specific mass, also called as mass density, or simply it is regarded as density. Okay, what is the denotion? Rho, symbol rho. What is the formula? Mass by volume. In formula we have mass, but it is dependent on mass or independent on mass? Independent on mass. What are the units? Units is kg per meter cube. How can we write kg as 1000 cube, 1000 grams? Meter cube can be written as 10 square, 10 square, 10 square, centimeter, centimeter, 10 centimeter. Okay, meter cube can be written as meter into meter into meter. 1 meter can be written 10 square centimeter, 10 square centimeter, 10 square centimeter. That is 10 to the power of 3 grams divided by 10 to the power of 6 centimeter cube. 10 power 6, 10 to the power of 3 gets cancelled. It is minus 3 will be remaining. It is going to the numerator, gram per centimeter cube. Okay, 1 kg per meter cube can be written as 1 by 1000th part of gram per centimeter cube. 10 to the power of minus 3 gram per centimeter cube. What have we discussed about here? Density is a which property? Density is independent on mass. Independent on mass. Density is which property? Then it is names is intensive, or it can also be regarded as intrinsic property. Intensive property or intrinsic property. Okay, this is an important points regarding the density. So density is having some standard values that we need to memorize. The standard values of densities are at 4 degrees Celsius. At 4 degrees Celsius. The first one is air, then we have water, then we have mercury. First of all, you need to remember these three: air, water and mercury for sure. In the problematic part, he is not going to give you these values we need to memorize on our own. Okay, followed by, what is the value? 1.2 kg per meter cube, 1000 kg per meter cube, 13,600. Some textbook gives 565, 570. That's also okay, but approx value is 13,600. Followed by, we having many other materials: wood, concrete, aluminium, then we have steel, okay, diamond and steel. First of all, I want to write in diamond, because in increasing order I will write the values here. Diamond, then we have steel, and the last heaviest are gold and platinum. Go through it. So what is the wood value? It's around 600. concrete 2400, aluminum 2800, diamond around 3000, steel 7850 as we discussed in the previous slide, gold 19,500, 24,500. All values are there in terms of what? Kg per meter cube. Units are same. Okay, go through it. Platinum. So these are the standard values of density at what temperature? 4 degrees Celsius. What is the meaning at 4 degrees Celsius, sir? What happens when temperature changes? As temperature changes, density also changes. We know that material usually expands upon heating. Okay, few materials contracts upon heating also. That is at water when we discuss at 0 to 4 degrees Celsius. Okay, if you see, for example, steel is there, temperature increases. As temperature increases, steel expands. When steel is going to be expanding, then molecular gap increases. When molecular gap increases, it is going to become rarer medium, that is density decreases. Density decreases. So the material which expands, which is having positive coefficient of expansion, in strength of materials you will be learning about this, positive coefficient of expansion. When positive coefficient of expansion is there, material expands. When material expands, then what happens to the density? Density decreases. But if you see water from 0 degrees Celsius to 4 degrees Celsius contracts upon heating. So molecules are going to be coming closer to each other. When molecules are coming closer to each other, then what happens? Then its density increases. Okay, 0 to 4 degrees Celsius. Then what happens? Density increases. That's why we are discussing about this 4 degrees Celsius. If you want to see a standard diagram, let me give it to you. That is, this is temperature, this is specific volume. Okay, this is the diagram that we need to know. Okay, here it is 0 degrees Celsius ice. Upon heating, what's happening? Observe, volume is decreasing, specific volume is decreasing up to what? 0 degrees Celsius, water. Focus on this diagram only. Okay, this line, volume is decreasing as temperature increases. Then temperature 1 degree, 2 degree, 3 degree, 4 degree, up to 4 degrees Celsius. You can see this is 4 degrees Celsius temperature. At 4 degrees Celsius, specific volume is minimum, that indicates density is maximum. Contraction, 4 degrees Celsius, density is maximum, that is 1000 kg per meter cube. At what temperature it is happening? 4 degrees Celsius. That's why all other materials density values also we are taking at what temperature? 4 degrees Celsius. After the 4 degrees Celsius, now the water is going to expand till how much? 100 degrees Celsius. Till 100 degrees Celsius. Then it is going to be converting from water, 100 degrees Celsius water, to 100 degrees Celsius steam. Expansion is there, expansion, and then superheated steam. So this is the temperature that we need to know about, that is 4 degrees Celsius. Okay, that is the concept behind why we are taking all the values at 4 degrees Celsius. Pause the video, note it down. Let me go to the back slide, previous slide here. Here we are having all the density values. We know the relation in between the temperature and density now. Why this 4 degrees Celsius is important also we discussed about. Let's go for the previous slide. Here we have all the density important points regarding the units, formula, intensive extensive property, unit conversion from kg to gram per centimeter cube. Here we discussed physical meaning of entropy also. Go through it. Okay, so this is all about the density concept that we need to know. Okay, now the next property that we need to discuss about after the density is specific volume. Okay, specific volume. Let's discuss about the specific volume. Specific volume formula is volume by mass. small v, volume by mass. What is the unit of volume? Meter cube. What is the mass unit? Kg, meter cube per kg. If you see the formula for specific mass, that is density, specific mass rho is mass by volume, that is kg per meter cube. Now upon comparison of these two, what we can say? That is specific volume and specific mass are dash quantities, reciprocal quantities, are reciprocal quantities. So what we can write here based on this reciprocal quantities? Note, specific volume is 1 by density, density is 1 by specific volume, specific volume into density is equals to 1. Go through it, both are reciprocal quantities. What is the density of water? 1000. What is the specific volume of water? 1 by 1000 it's going to become. Okay. Example, density of water equals to, standard value is 1000 kg per meter cube. Then specific volume of water is going to become 1 by 1000 meter cube per kg, 10 to the power of -3 meter cube per kg. So that's how we're going to change all the density values in terms of specific volume values. Go through it, pause the video and note it down so that we can go for the next slide. So now we know about mass, specific mass, then specific volume and volume. The next property that we need to discuss about after the area, volume, mass, specific volume is weight. The next property that we are going to discuss about is weight. Weight is a force. As force is mass times acceleration, weight is mass times acceleration due to gravity. Mass times acceleration due to gravity. Okay. This is coming from a Newton's law of gravitation, where F is equals to G m1 m2 divided by r square, where F is equals to G mass of the earth divided by radius of the earth whole square times mass of body. This entire value is going to give you what? Acceleration due to gravity, and this force is going to become weight. This is acceleration due to gravity, this times mass of the body. Acceleration due to gravity value is 9.81 times of mass of the body, with which now we know that weight is a force. Weight is a force. What is the standard unit of force? Newton. So unit of weight is Newton, SI. Okay, SI unit of weight is Newton. There is one more unit that we need to know about, that is gravitational unit of force. What is it? Gravitational unit of force, that is 1 kg force, 1 kg F, 1 capital F is equals to 9.81 newtons. This we need to memorize. Okay, 1 kg equals to 1 kg force is equals to 1 capital F is equals to how many newtons? 9.81 newtons. For example, if the question is given like this, 1 ton force TF, 1 ton force, 2 TF, 3 TF, 10 TF, ton force is given. Ton indicates what? 10 cube. This F indicates what? 9.81 newton. So it can be written as 9810 newtons. So this is all about the weight that we need to memorize. What is the formula for weight here? Weight is equals to mass times gravity. Weight equals to mass times gravity. What are the two units that we are going to memorize about the weight? SI unit of weight, SI unit of force, that is Newton. One is gravitational unit of force, that is kgf. F, 1 capital F, 1 kg equal to how many newtons it is? 9.81 newtons. Actually what we are going to do is converting the mass into mass times acceleration due to gravity. Converting the mass into mass times acceleration due to gravity to make it as newtons. Okay, that's how we convert the masses in terms of Newton forces, by multiplying with what? 9.81. Go through it. So Pause the video and note it down so that we can go for the next property. So the next property that we are going to discuss about is specific weight. The next property is what? Specific weight. Specific weight. Specific mass is mass density. So specific weight is also called as weight density. Specific weight is also called as weight density. What is the formula for specific mass? Mass by volume. So specific weight formula is gonna become what? Weight acting per unit volume. Weight is a force. That is how much body weight is going to be acting or a given volume is called as specific weight. Okay. So as we can write specific weight as gamma. Gamma is equals to weight divided by volume. What is the formula for weight? Mass times gravity divided by volume. What is mass by volume? Mass by volume is density. So density times gravity. What are the units? Units going to become? Weight unit is Newton. Volume unit is meter cube. So this is Newton per meter cube. This is the units. Then what are the standard values of the specific weight? Sir, specific weight is equals to rho g, that means density value into 9.81. Do we know the values of densities of air, water, mercury? Yes, we know. Okay, all the substances we have written the density values already. Then what is the specific weight? Density into 9.81. What is the density value? 1.2. So the answer is 1.2 into 9.81. What is the water density? 1000. 1000 into 9.81. That is 9810 Newton per meter cube. What is the mercury density? 13,600 into 9.81. So that's how we'll be getting the values for specific weight. Remember, specific weight is having two formulas now. Specific weight is equals to, some textbook gives gamma, some textbook gives small w. Formula is weight acting per unit volume or density times gravity. Go through it. Regarding the specific weight, weight density and specific weight, weight density can be written as weight divided by volume. Okay, chalo, pause the video and note it down. Congratulations guys, you have made it so far. ఈ వీడియోని ఎంటైర్ గా వాచ్ చేసినందుకు ఖచ్చితంగా మీకు లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ అవర్ ఛానల్ గైస్. అండ్ సార్, వాట్ ఇస్ ద గోల్డెన్ ఆపర్చునిటీ దట్ ఇస్ ప్రొవైడెడ్ బై SAIMEDHA? SAIMEDHA is starting AE-AEE civil వాళ్ళకి న్యూ బ్యాచ్ అనేది మనం స్టార్ట్ చేస్తున్నాం అండ్ కండక్టింగ్ a talent test examination. Talent test examination లో సిలబస్ is what? Fluid properties. ఇదే fluid properties ఉంటది. 11th of February you are going to be writing the examination sharp at 10 o'clock in the SAIMEDHA premises. Those who are going to be attempting the test guys, my dear students, based on your marks you will be getting the maximum concessions 85%, 87, 89, 90, 95 up to 100% concessions అనేది ప్రొవైడ్ చేయడం జరుగుతుంది. ఫ్రీ ఎడ్యుకేషనల్ కాంటెంట్ అప్డేట్ అవుతుందంటే ఖచ్చితంగా లైక్, షేర్ అండ్ సబ్స్క్రైబ్ అవర్ యూట్యూబ్ ఛానల్. మీకు ఏ డౌట్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ అటెంప్ట్ ద టాలెంట్ టెస్ట్ ఎగ్జామినేషన్ వితౌట్ ఫెయిల్. థ్యాంక్ యూ వెరీ మచ్ guys with one more fresh video, new educational content, free content in our YouTube channel. I'll come back one more time. Since then, until then, keep learning with the SAIMEDHA YouTube channel.